Abhishek Misal welcome you to this comprehensive topic of Op Amp, Adder and Subtractor. In previous lecture, you study about the Op Amp and its characteristic. The main function of Op Amp is amplification of input signal. There are different conditions are available like inverting and non-inverting terminal. You study all these conditions in previous lecture. Now, we are moving to the main objective of our lecture is principle and application of adder and subtractor circuit. The first topic is introduction of Op Amp adder circuit. The Op Amp adder circuit, also known as a summing amplifier, is a fundamental application of operational amplifier. It is used to add multiple input voltage together. This circuit is practically useful in various electronic applications, where you need to combine or sum different analog voltage. Here is a detailed breakdown of Op Amp adder circuit. The Op Amp 2 input adder circuit is simple, but fundamental circuit used to add two input voltage together. It is a specific type of the more general Op Amp adder circuit with multiple inputs. In this circuit, we will have two input voltage and the output will be sum of these two voltage. Let us break down the component and how this circuit works. Op Amp 2 input adder circuit diagram. In this circuit diagram, you can understand the circuit configuration of Op Amp, which is shown in this slide. Now, the components of operational amplifier. As with other Op Amp circuit, the Op Amp is the central component. It has two input terminal, the inverting and non-inverting input, and one output terminal. In this circuit, the non-inverting input is usually grounded, or you can say it will be provided a 0 voltage. The next component is input resistor. R1 and R2 are the two resistors which is used. These resistors are connected in series of inverting terminal or input terminal of the Op Amp. Input voltage sources are connected through this input resistor. The voltage from each source is applied across its respective resistor. The next is feedback resistor. The feedback resistor, labeled as RF, is connected from the output of Op Amp to the inverting input terminal RF, play a critical role in determining the gain of Op Amp. 2 input adder circuit. Now, in this stage we will discuss how the circuit work and or the working condition of. In this stage we will discuss the first input voltage source V1 and V2. These are two input voltage you want to add together. Each voltage source is connected through its resistor. Input resistor R1 and R2 to the inverting inputs of Op Amp. Now, let us discuss the mathematical expression of Op Amp 2 input adder. The mathematical expression for an operational amplifier adder circuit can be delivered by analyzing the circuit using the principle of ideal Op Amp behavior and Kirchhoff current law. The Op Amp adder circuit combine multiple input voltage and produce an output voltage, that is the algebraic sum of input voltage, each multiply by a specific gain or factor. The general expression of output voltage in Op Amp adder circuit with two input is as follow. The first output is V output is equal to minus R f into V 1 upon R 1. Here we using the inverting terminal, that is why the output is minus, where the V output is the output voltage of the op-amp adder circuit, V 1 are input voltage, R 1, R 2 are the input resistance connected to each input voltage source. R f is the feedback resistor connected from the op-amp output to its inverting input. In this expression, the negative sign indicate that op-amp inverts the sum of the input voltage. It is discussed earlier in this topic. Once again I just clear this. If you do not want inversion, you can remove the negative sign, resulting in a non-inverting op-amp adder circuit. The gain of each input voltage V 1, V 2 is determined by the ratio of the feedback resistor R f to the corresponding input resistor R 1, R 2. To clarify, let us consider an example of simple inverting op-amp adder circuit with two input voltage. V 1 is connected to R 1 and V 2 is connected to R 2. R f is the feedback resistor. The output voltage of these two input inverting op-amp is adder circuit is V out minus R f V upon R 1 plus V 2 R f upon R 2. In this case, the output voltage is negative sum the two input voltage each multiply by corresponding gain factor R f upon R 1 and R f upon R 2. The negative sign indicate that the output is inverted compared to the input. By adjusting the value of resistor and the configuration, you can create various op-amp adder circuit with different gain factor and number of input to suit specific application. In this circuit, we discuss the behavior of op-amp. The op-amp with its high gain try to keep its inverting input voltage equal to its non-inverting input voltage, which is typically grounded in this circuit. The op-amp will adjust its output voltage to make the voltage at the inverting input equal to the weighted sum of input voltage. The next is feedback resistor. Once again, it is a important component of the op-amp and this is represented by R f. R f determine the proportion of the output voltage, that is feedback to the inverting input. By using the negative feedback provided by R f, the op-amp ensure that the sum of the input voltage is equal to the voltage at its inverting input. Now, we discuss once again the output voltage equation. The output voltage of op-amp 2 input adder circuit is calculated by using this equation, that is V out minus in the bracket R f upon R 1 V 1 minus R f upon R 2 V 2. In this equation, each input voltage V 1 and V 2 is multiplied by factor determined by feedback resistor and the respective input resistor R 1 and R 2. The negative sign indicate the inputs are subtracted, resulting in their summation. We can too much pressurize or emphasize the equation, that is very much important in adder circuit. So, each and every student have to clear this equation. That is why we repeatedly show the mathematical expression of this expression. Now, the op-amp 2 input adder circuit is used in various applications, where you need to combine or sum 2 input voltage. Common application is audio mixing, or you can say summing of 2 audio signal. The second is analog signal processing, and next is basic mathematical operation in electronic circuit. The op-amp also a variety that is called multiple input adder or summing adder. The op-amp multiple input adder circuit, often referred to as the summing amplifier or simply an adder, is a fundamental circuit used to combine multiple input voltage into single output voltage. This circuit is versatile and finds application in various fields of electronics, including audio signal processing, instrumentation and analog computing. Here we will explain the components and working of the op-amp multiple input adder circuit. Op-amp multiple input adder circuit shown in below. In this circuit, you will be see that there are so much input, or you see that V1, V2, V3 are connected with resistor R1, R2, R3 dash 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 R1. So, you can connect it n type of input voltage with the help of resistors, and then we are using the one feedback which is shown in the, which is connect R1, R2, R3 dash 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 R1. These resistors are connected in series or to the inverting input terminal of op-amp. Each input resistor connected to an input voltage source V1, V2, V3 dash 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 Vn. The voltage form of each source is applied across its respective input resistor. The one of the most important resistor is feedback resistor. The feedback resistor labeled as Rf connected to the output of op-amp to the inverting input terminal. Rf determine the gain of op-amp multiple and input adder circuit. Now, the working of this circuit, once again we have to same method. Here we using the input voltage source V1, V2 dash V3, and so here we move from the n. These are the n input voltage that each want to sum together. Each voltage source is connected through its respective input resistance R1, R2, R3 dash dash R1 to the inverting input of op-amp, as you saw in the previous figure. The op-amp behavior. The op-amp with its high open loop gain attempt to keep its inverting input voltage equal to its non-inverting input voltage, usually grounded or 0 voltage, as we consider in the 2 input adder circuit. This circuit is a virtual ground at the non-inverting input. The op-amp adjusts its output voltage to make the voltage at the inverting input equal to the weighted sum and input voltage. Feedback resistor. Rf play a crucial role in determining the scaling factor of input voltage. In the output, by changing the value of Rf, you can adjust the gain of circuit. The negative feedback provides by RF ensure that the sum of input voltage is equal to the output at the inverting input voltage equation. The output voltage V out of op amp multiply input adder circuit can be calculated using the same equation which is done previously, but here the number of inputs are increased and the number of inputs are n. So, in each input voltage, so each input voltage V 1, V 2, V 3 dash dash V n is multiplied by a fraction representing the relationship between the feedback resistor RF and the corresponding input resistor R1, R2, R3 dash. It's move on to the Rn. The negative sign indicate that the inputs are subtracted, resulting in their summation application. The op amp multiple input adder circuit is widely used in various application, including an operational amplifier. Adder circuit is a common electronic circuit used to add multiple inputs voltage or signals together. It is also known as an op amp summer circuit. This circuit is useful in various applications where you need to combine of some different signal. Here is some practical application of op amp or op amp adder circuit. Audio mixing. One of the most important and widely used application is audio mixing. Op amp amplifier adder circuit are commonly used to audio mixture to combine multiple audio signal from microphone, instrumentation or other source into a output. This allow us for the creation of a composite audio signal. This circuit is used basically recording or studio or anywhere multiple instruments are playing and people are listening. In this condition, you can connect this output to this amplifier and you can use it, and it give the much more better output as compared to the normal condition, previous condition, or it help us to reduce the noise also. That is why some people feel that in the TV or audio system they listen good music and viewing the TV as compared to the live performance. The next is signal conditioning. In instrument and sensor application, op amp adder can be used to combine the signal from multiple sensor or transducer before further process. This help suitability the overall signal conditioning circuit. The next is weighted sum. Op amp adder circuit can be configured to perform weighted summation, where each input signal is multiplied by a specific weight or coefficient before adding them together. This is often used in control system to calculate weighted average or perform control calculation. The voltage scaling. By using appropriate resistor value in the adder circuit, you can scale and offset multiple input voltage to obtain a desired output voltage level. This is useful applications such as level shifting and voltage range adjustment. Audio equalization in audio amplification, op-amp adder can be used to implement the graphic equalizer which adjusts the amplitude of different frequency band in an audio signal to achieve the desired frequency response characteristic. Now, the major use of op-amp in control system, op-amp adder circuit are employed to control system to some error signal, reference signal and feedback signal. This is commonly seen in PID, proportional integral derivative, controller and other feedback control system. The next topic is data acquisition system. Very popular topic is data. So, people are using to analyze so much data. For this data, we are using the sensor or system where we use the op-amp to data acquisition system. Op-amp address can be used in data acquisition system to sum multiple analog inputs signal which can be digitalized and processed by a microcontroller or FPGA for various applications include data logging and measurement. Op-amp the voltage reference. Op-amp adder can be used to create precise voltage reference by summing the output of multiple voltage divider, ensuring a stable and accurate reference voltage for other circuit. Signal averaging. In signal processing application, op-amp address can be used to calculate the average of multiple input signal over time, which help to reduce noise and improve signal to noise ratio. Amplifier gain control. Op-amp address can be a part of circuitry that adjusts gain of amplification or an amplifier based on multiple input signal. This can be used in automatic gain control circuit for receiver or amplifier. In all these application, op-amp adder in all these application, op-amp adder circuit provide a flexible and versatile means of combining versatile mean of combining multiple signal while maintaining good accuracy and minimize signal distortion. The specific design and component value of the adder circuit can be tailored to meet the requirement of each application. In some analog computing application, you might need to add or subtract analog computing application, you might need to add or subtract analog voltage to perform mathematical operation. Op-amp adder are well as op-amp subtractor are useful in such a case. For this case, we have to study the subtractor. The first type is 2 input subtractor circuit is a fundamental circuit used to calculate the difference between 2 input voltage. It a specific application of operational amplifier and it is commonly used in various electronic system for tasks like signal condition, differential measurement and instrumentation. Let us break down the component and how this circuit work. The first thing is circuit diagram. In this circuit diagram, you can see the connectivity of the input voltage and output voltage. In this diagram, you see that the input voltage V 1 and V 2 are connected differently or different point, and the feedback is also connected in the same as a adder circuit and output is taken. Now, we will discuss the component of this subtractor circuit. The op amp is core component of the circuit. It has two input terminal, inverting and non-inverting, and the non-inverting input is usually connected to a reference voltage or ground, creating a virtual ground or 0 voltage input resistor R 1 and R 2. These resistors are connected in series to the inverting input terminal of the op amp. The input voltage source V 1 and V 2 are applied through this input resistor. Each resistor is connected to one of the input voltage. Now, once again feedback resistor. The feedback resistor labeled as RF counters. The output of the op amp is inverting input terminal. RF determine the gain and behavior of the op amp two input subtractor circuit. Now, let us discuss the working of circuit or how the circuit works. In this case, the first thing is input voltage. The input voltage is V 1 and V 2. These are the two input voltage that you want to subtract from each other. Each voltage source is connected through its respective input resistor R 1 and R 2 to the inverting input of op amp. The behavior of op amp. The op amp is the high open loop gain attempt to keep its inverting input voltage equal to its non-inverting input voltage, usually ground or a reference voltage. In this configuration, the non-inverting input is typically at ground potential, creating a virtual ground. At that point, the op amp adjusts its output voltage to make the voltage at the inverting input equal to the difference between the two input voltage. Once again, feedback resistor, we discuss this resistor same repeatedly, but you have to knowledge that feedback and importance of negative feedback. So, RF play is a crucial role in the determining the scaling factor of the output voltage. By changing the value of RF, you can adjust the gain of circuit. Now, once move to the output voltage equation, the output voltage of the op amp circuit two input subtractor can be calculated using this equation, that is V out is equal to minus RF upon R 1 into V 1 minus RF upon R 2 into V 2. In this equation, each input voltage V 1 and V 2 is multiplied by a fraction representing the relationship between the feedback resistor and respective input resistor R 1 and R 2. The difference between these two terms is the output voltage, which represent the subtraction of two input voltage. Now, we discuss the multiple input subtractor circuit diagram, which is shown below. In this subtractor diagram, the op amp is core component of the circuit. It has two input terminal, inverting and non-inverting, and one output terminal. In this circuit, the non-inverting input is usually connected to a reference voltage or ground, creating a virtual ground. Input resistance R 1, R 2, R 3 and it is moved to the N resistor. These resistors are connected in series to the inverting input terminal of op amp. The input voltage source V 1, V 2, V 3 dash or and move to the N voltage are applied through this input resistor. Each resistor is connected to one of the input voltage. The once again we using the feedback resistor. The feedback resistor labeled as RF connected the output of op amp to inverting input terminal. RF determines the gain and behavior of op amp to input subtractor circuit. The working of this circuit is first input voltage source, that is V 1, V 2. These are two input voltage that you want to subtract from each other. Each voltage source is connected through its respective input resistor R 1 and R 2 to the inverting input of op amp. The behavior of op amp is the op amp with its high open loop gain attempt to keep its inverting input voltage equal to its non inverting input voltage, usually grounded to reference voltage. This configuration, the non inverting input is typically a grounded potential, creating a virtual ground. At that point, the op amp adjusts its output voltage to make the voltage at the inverting input equal to the difference between the two input voltage. Then once again RF. Why we use RF? RF play a crucial role in determining the scaling factor of the output voltage. By changing the RF, you can adjust the gain of the circuit and the output voltage equation of the op amp is shown below, where the number of inputs are n and we each are multiplied with RF upon respective resistor, like first is RF upon R 1 multiplied by V 1 minus RF upon R 2 multiplied by V 2 minus RF upon R 3 multiplied by V 3. It is going on to RF upon R n and it is multiplied by V 1. In this equation, each input voltage V 1 and V 2, V 3, V 4 is multiplied by a fraction representing the relationship between the feedback resistor RF and the respective input resistor R 1, R 2, R 3, R n. The difference between these two terms is the output voltage, which represent the subtraction. Now, we move to the applications of the subtractors. The application, the op amp 2 input subtractor has various applications, including differential voltage measurement, subtracting a reference voltage from a single to measure the difference signal condition, pre-processing signal to obtain the desired output, error amplifier, calculating the error between two signal for control system, instrumentation, performing differential measurement in precise instrumentation by adjusting the value of input resistor R 1 and R 2 and feedback resistor RF. You can customize the circuit to achieve the desired level of subtraction and amplification for your specific application. And now you can discuss the now there are so much application widely you can study or you can explore these application. From this I conclude my lecture and thank you for watching.